Hey everybody, and today we're going to be doing a super quick Christmas special. I guess I have 15 minutes to make this video. So let's hope I can get this done before Christmas. Let's go, guys. So we're going to be looking at which one is bigger, 24 to the 10th or 25 to the 9th, without calculators and without, graphing. Super number crunchy, not super elegant method I have here, but we're gonna do it regardless. So we're gonna start by taking log base 3, we can draw G's, of both ones. So 24, and by log properties we're gonna have the 10 out the front as a coefficient instead of a power, and then we're gonna have the 9 out front for log base 3 of 25. Super rushed right now. I have still 15 minutes. Okay. So these aren't very easy to calculate, but the reason I chose log base 3 is because we can actually estimate this. So we know that log base 3 of 27 is just 3. And the derivative of log base 3, so let me write this down here, f prime of x is equal to 1 over x ln 3. So now we can plug in 27 here and multiply by the difference between 24 and 27 and 25 and 27. So we're going to have two things. We're going to have, 24 minus 27 is negative 3, so we would have negative 3 over 27 ln 3, and we're going to have negative 2 over 27 ln 3. So now this is great, because now we can subtract these from 3, which is the value we do know, the f of x value that we do know, to estimate both of these logs, and of course we're still going to have the coefficients out front, so you would ultimately end up with 10 times 3 minus 3 over 27 ln 3, and 9 times 3 minus 2 over 27 ln 3. Now we're gonna do more estimation. I need some more space, so I'm gonna erase that. Here we go. Let's color this out. So now we're gonna estimate ln 3, because that's not exactly a value that we know, but thankfully we do know ln of e. So things are falling into place here. So we know that ln of e, that is the worst e I've ever drawn. E, okay, is equal to 1. And the derivative of ln of e, so we're going to have f prime of x again, but this time for ln of e, or just ln of x, is 1 over x. So we plug in e, we're going to use the decimal approximation of e, so we're going to have 1 over 2.718. Let me drop it over here. 1 over 2.718 multiplied by the difference. Since we're having ln of 3 as the input, or 3 as the input into our natural log here, we only have to do this once. So 3 minus 2.718 is let me write a 0 so it doesn't look confusing. 0.282, so we get 0.282 over 2.718. Now you could do the full division out, but e is transcendental. It's just not fun, right? So this is approximately equal to 1.1, and this makes sense as 3 is pretty close to e, only a difference of 0.282, some more numbers, but you get the point. It's pretty close. We can estimate it to be about 1.1. Had the cough. Okay, so this is good, because now we can just plug in 1.1 for ln of 3 here. So we're going to have two different things again. So we have 10 times 3 minus, and we can reduce 3 and 27, so it's going to have 1/3, and 3 times 1.1 is 3.3, so we would have 1 over 3.3. Now this is a pretty easy division problem. 1 over 3.3 is just like 0.303 repeating. So let me write this here. We're not going to use the repeating, it's just a little annoying. So we're going to have 3 minus let me write a minus, 0.303. So this gets us ultimately 10 times, we can just do this out, 2.697, which ultimately gets us 26.97. Now this is our estimation for 10 times log base 3 of 24. Remember, that is essentially 24 to the 10th. Obviously, the values are going to be vastly different, but if 24 to the 10th is bigger, or if it's smaller, then taking the log of it, regardless of what the base is, should still provide a smaller or bigger number to 25 to the 9th. So it's totally okay. So now, 10 minutes, I can do this. So we have 9 times, and then of course 3 minus, this time we can't actually really simplify this out. Well, I guess we could. I'm lying. Okay, so we have 3 minus 2 over 3 or sorry, no, we can leave that, 1.1. Just put this in parentheses. We're going to be multiplying this by 1/9 just to keep it the same. So now we have 9 times 3 minus 2 over 3.3 times 1/9. And now we have 9 minus, sorry, should be 3 there, not minus. 3 minus, now 2 over 3.3 is about not 6. Is it 6? 0.6? Yeah. Okay. 0.606. Now it repeats, which is a little annoying, but we're just going to use a shorthand decimal approximation. So then, of course, we would then ultimately have 9 times, now 3 minus 6, or sorry, we do multiplication out first. So, oh, PEMDAS, oh no. So, 3 minus, that is an awful looking 3. I don't know why I'm rushing. I have 8 minutes. 3, what am I doing? I need more space. Okay, 3rd time's the charm on writing a 3. Okay, I'm actually brain dead. We still need this 3. Minus. Okay. Good job, Justin. You are, I guess I'm just a little tired or something. I need more space. We're gonna go up here. So 6 or 0.606 is about, sorry, 0.606 over 9 is about 0.06734. You know, if you want to do the division. So we would have 9 times 3 minus 0.06734. Now this is simple subtraction. We would have 9 times, not 3 minus, it's going to be 2.93266, which if we multiply this out, this is pretty close to 3, so it's going to be a little less than 27. But ultimately, we get about, what do we get? What do we get? We get, there we go, 26.39. I'm not going to have enough space. 3.94. That is our estimation for 10, or sorry, not 10, 9 times log base 3 of 25. We'll call that B. This right here I have decided now is A, and this is B. So this is B, and where's our other estimation? Here, right here. This is A. Now, of course, 26.97 is in fact greater than 26.39394. Now, I estimated heavily on this whole thing. We're going to erase all this so I can have a quick elegant way to round out this not very elegant method. Wow. Let me paint everything black real quick. Okay, it's a little messy, but it'll suffice. So 26.97 is greater than, looks kind of like a 7, greater than 26.393. I have 5 minutes. 4. Therefore, because this is an estimation of 10 times log base 3 of 24, we can say that 24 to the 10th, so let me write this out here, 24 to the 10th is in fact greater than 25 to the 9th. So yeah, thank you for watching. Awful, not very elegant way, but I hope this is at least semi-interesting as a Christmas special, I guess. I have 4 minutes now, so I'm gonna see if I can upload this in the time frame Christmas is still technically ongoing. So yeah, thank you for watching.